So just to provide a quick introduction, Joe Hezir, has joined former Secretary of Energy Ernest Moniz and fellow Principal Melanie Kenderdine in founding Energy Futures Initiative, which is a nonprofit organization dedicated to driving innovation in energy technology policy and business models. He's Principal and Executive Vice President. He's the lead on key EFI projects, including reports determining and examining federal support for carbon removal research technologies, U.S. nuclear enterprise, and key role in national security, and white papers on the Department of Energy's budget priorities. He's also currently a member of the advisory board of the Scott Institute for Energy Innovation at Carnegie Mellon University. Previously, he served as the Chief Financial Officer and Senior Advisor to the Secretary of Energy, Ernest Moniz, from 2013 to 2017. So thank you, Joe, for coming to our conference today. Looking forward to your remarks, and we'll cede the floor to you. So thank you. And
thanks to Marcus for the great setup. I thought he gave a great overview of the opportunity space here. Neil's going to help me with a few slides here, but let me go ahead and get started. So at the Energy Futures Initiative, our focus has been on the innovation agenda for CDR and what we kind of generally refer to as technologically enhanced carbon removal. You know, looking back now, it's really hard to imagine that the very first major study by the Department of Energy on carbon removal was undertaken in 2016 at the direction of then Secretary of Energy Moniz. And thinking about that now, a great deal has happened over the course of the last 4.5 years. And really, I think this event today is great evidence of that. At EFI, we were formed in 2017, and our mission, as Jason indicated, simply stated, is to advance a low carbon economy through innovation in technology, policy, and business models. And carbon removal has become one of our priority focus areas as part of that innovation agenda. So beginning in 2018 and then extending through 2019, we undertook a comprehensive study looking at a federal CDR research, development, and demonstration, or RD&D initiative. And at the time we did that work, we were following closely behind a major scientific study that was being undertaken by the National Academy of Sciences. And our goal, quite simply, was to kind of translate those scientific priorities into some form of a operational federal program. One of these pathways, direct air capture, or DAC, has now generated a lot of interest, and I think is evidenced by the title of this group, AirMiners. But we believe that other CDR pathways also held a lot of potential. So we followed our initial report with 3 other reports targeted to the other principal pathways for carbon removal, that being biological and terrestrial CDR, OceansBased CDR, and carbon mineralization. So I know there's a lot of AirMiners in this group today, but I hope that we also have a few that will also be interested in becoming oceans and terrestrial harvesters as well. So let me turn to some of the specifics takeaways from our work. So Neil, if you can go to the next slide. This slide summarizes the original study that we did in 2019. And there's really 4 major takeaways here. First of all, we recommended that the CDR research, development, and demonstration really needs to take into account all pathways, not only direct capture from the air, but also what we refer to as technologically enhanced biological, marine, and mineralization CDR. The second thing that we identified in our report was that this is really not just simply a mission for the Department of Energy, or for that matter for the EPA, but it really spans across a number of federal agencies, 10 in all. And it really requires some really high-level coordination out of the White House through the Office of the Science Advisor, as well as the Office of Management and Budget, which ultimately controls the purse strings for all of these programs. The third major takeaway that we came up with is that we built a tentative budget for this initiative totaling over $10.7 billion over 10 years, spanning all 10 agencies. And this also poses a real challenge on the congressional side, because there are 6 separate bills where this funding would be showing up. But the bulk of it, about 60%, would be in the Department of Energy. And then last but not least, we identified a fairly detailed and comprehensive research portfolio where we identified 27 different specific elements for research and development. So our 2019 study gathered a lot of attention in Congress. Former Secretary Moniz testified on this several times. We had in the Senate implementing legislation introduced on a bipartisan basis, and Congress began to ramp up the funding for CDR programs, mainly focused on DAC. I would just point out that DOE has received $90 million in new funding for CDR research in the current fiscal year, with most of that, though, earmarked for DAC. So our follow-on 3 reports sought to draw more attention to the other CDR pathways to try and identify what the opportunity space was, as well as to define some of the research priorities. And so I'd like to just highlight a few takeaways from our other 3 reports. So Neil, if you can go to the first slide on terrestrial and biological. The key takeaways that we recommended in this area are the need to really work hard to identify opportunities to apply the tools now of synthetic biology to non-food crop plants. Secondly, another major thrust of our report was finding ways to shift from annual to perennial plant varieties as a way to improve and preserve soil management. A third area was in system approaches to better understand the full ecosystem effects of capturing more carbon and keeping it in the soil. And then last but not least, there clearly was a significant need for expanded data collection, data analytics, and life cycle analysis. And the picture here shows what could be done with a synthetically engineered plant to improve its root system, to deepen those roots, to improve the carbon uptake, as well as to improve the ability to move that carbon into the soil and to move it into deeper levels. Some of this work was being pioneered outside of the federal government by the Salk Institute, and we're hoping now that with some government funding, this work can be greatly expanded and accelerated. So if we go to the next slide on oceans-based CDR, again, this tends to be an area that has gotten much less attention and one that probably has a bit more controversy. In our report on oceans-based CDR, we identified the need to look at both biological and chemical methods to foster carbon capture, and to do it at both through microorganisms and macroorganisms, including sea plants. One of the things that we found was that while there had been some limited experiments in this field over time, they were not very well controlled or well defined. And so there's a real need here for controlled experimentation to better understand what the potential benefits might be, as well as to understand the ecosystem effects, including the potential here for co-benefits in terms of increasing nutrients for marine organisms. Also, clearly is a need in looking at the complexity of the oceans to improve our ability to model those interactions. And lastly, we did make a very strong recommendation here that there's a real strong need to improve public education and engagement, and as well as to improve international collaboration. What we found in doing our work here was that the European Union really was taking the lead in doing CDR projects in this area, and we were hoping that the U.S. would begin its work in this area by joining in to some of that international work that was based in Europe. And so last but not least, I'd like to turn to carbon mineralization. And again, there's a lot of different pathways here to be considered, both ex situ methods as well as in situ methods. One of the things that we found is that there have been a lot of experiments in the laboratory, and we think we understand the chemistry and the thermodynamics of carbon mineralization. But what we really don't understand is how those thermodynamics would work and what the real rate of kinetics would be. In other words, how quickly can you affect the rate of mineralization in the real world? And so we very strongly recommended the need here for real world field tests. And we thought that the best way to do this was through private-public partnerships that would establish regional test centers where various methods of carbon mineralization can be tested and compared, and doing it on a regional basis so that we also can understand the effects in different climatic regions. So just to go on from there, we believe that these various RD&D initiatives can really form a very powerful innovation pipeline so that the sort of the nascent carbon removal industry can expand and become an increasingly significant contributor to achieving net zero emissions and ultimately net negative emissions. And beyond that, clearly there's a potential to go to net negative CO2 emissions as a way to address legacy CO2 levels residing in the atmosphere. So finally, I'd like just to point out to you several recent and potential new federal government initiatives, I think, that would help to incentivize carbon removal demonstration and deployment activities, and hope that these would be things that you could think about as you go through your panel discussions later today. First, with respect to government funding, as I pointed out earlier, in the current year, we've now gotten in DOE new funding of $90 million a year, and we're hoping to not only increase that in the next fiscal year, but also to expand those programs into other agencies. And I think given the appointments made in the Biden administration, we're looking to see a lot of support for doing that. Secondly, I think many of you are aware that the Energy Act of 2020, which was passed at the end of the last Congress, extended the availability of the 45Q tax credit, which is absolutely essential right now as a financial incentive for DAC deployment projects. That act also has some other provisions, most notably that it established a federal government carbon removal prize program, separate and apart from the one that X Prize is running, and the one that is being run by private sources. And the government program would have two separate levels of prizes based on technological maturity. A prize program for commercial deployment of DAC, and a second prize program for a broader range of pre-commercial carbon removal technology demonstrations. And so looking ahead, what we see are some potential additional opportunities for advancing CDR demonstration and deployment activities on several fronts in the current administration and the current Congress. The first is we're looking ahead to expanded legislation, authorization, and funding for federal cost-shared CDR demonstration projects, and ones that span all forms of CDR pathways. Secondly, we see the potential here for further enhancements to the 45Q tax credit, not merely to extend the dates, but also potentially some changes that might increase the value of the credit, as well as expand eligibility to some of these other forms of CDR. And that lastly, we're hoping to see bipartisan legislation in the House as well as in the Senate to advance many of the recommendations that we made in our 2019 EFI Clearing the Air report. So clearly, I would say in conclusion, I think our work has indicated that carbon removal pathways, once properly demonstrated and deployed, have the potential to evolve to a gigaton scale, which is what is going to be needed to address the climate crisis. And we also believe that even in the nearer term, carbon removal can make important contributions, for example, to the nationally determined contribution, or NDC, for 2030 that was recently announced by President Biden. We've done some back of the envelope calculations about this, and we believe that there's a potential here that between now and 2030, we could see potential CDR deployment in the range of hundreds of megatons of CO2 removal per year by 2030, which, when comparing that to the total reduction that's needed to meet the 2030 target of 50 to 52% reduction, means that we could be in the range of 10 to 15% of total reductions between now and 2030 coming from various forms of CDR, not only the direct measures, but also some of the technologically enhanced measures, particularly with respect to the terrestrial biological sector. So with that, I wanted to sort of thank you to the opportunity to kind of run through some of these ideas with you today. And to all of you who are practitioners in the AirMiners space here in this audience, best of luck to you as you move forward with your various projects. So with that, I'll end here and turn it back for any questions.
Joe, thank you so much. So if you have questions, please put them into the chat. I actually have a question for you, Joe. You'd mentioned, but by the way, again, great talk. Interesting that we've had two keynotes and each of them alluded to prize competitions that are being run in carbon removal. My question is about, again, ocean and land-based and mineralization CDR methods. For the 45Q tax credits, you talked about expanding those credits to encompass those additional methodologies of capturing carbon. I'm myself curious how, what are some of the most important barriers to those? Is it a monitoring, verification, and reporting? Are there other barriers to seeing those come to pass?
I think there's two major challenges there. One being defining the scope in terms of what would be an eligible type of a project that would be eligible for the credit, because in defining the scope, you're also then defining the cost and the scale. And then the second one is the point that you made, Jason, about the monitoring, reporting, and verification of the actual reductions. So it's not easy. That's one reason why they were not included originally in the 45Q. But as I think as we're now learning more about how some of these other techniques, we're beginning to potentially build the kind of database that we need so that we can begin to define those policies.
Great. So let's see. Question from Joe. Are you still with us?
Yeah, I'm here. I see one on my screen from Kate Levy. I guess it really came up earlier, and I'm happy to address it, which is how much energy is needed for CDR processes and the conversion of clean power needs to dovetail to support CDR. That is a very, very, very critical issue. what we know, particularly with respect to DAC, is that chemicals such as amine capture can be very effective in capturing CO2. The problem is that regenerating the amine and separating the CO2 from it is energy intensive. And so one of the major priorities in our first report that we identified was the need to develop new classes of sorbents that can not only effectively capture the CO2, but can be regenerated with a much less energy penalty. There's been some very interesting work that was done in the past several years by Jen Wilcox, one of the leading researchers in this area, who is now at the Department of Energy and will now be leading this program. But Jen's work, I tried to identify opportunities to use waste heat, for example, or waste energy as a source of energy for regeneration. And I think there obviously will be some location-specific opportunities for that, but we're going to need a lot more than that. And kind of finding these new classes of materials and sorbents, I think, is going to be one of the very important research needs, because otherwise that will tend to become over time a potential limiting factor to deployment.
Great. Yeah, I mean, to that end, that's exactly why we had a nuclear-powered direct air capture event in December, which you can look at on our AirMiners YouTube channel. But also, we've also had Jen Wilcox on in June of last year to deliver an excellent talk, to your point, Joe, about DAC and sorbent technologies and energy requirements. So look forward to more on that front. One maybe last question here is, how do you think about how much funding is necessary or effective to stimulate R&D? And have you looked at things like success stories in hard science companies and the levels of funding that they need?
In our 2019 report, as I said, we came up with a 10-year estimate that was a little over $10 billion. And with it ramping up into the hundreds of millions of dollars over the next 3 to 4 years. And we think that a lot of that really needs to be placed, that research work needs to be placed in universities as well as government laboratories and cost shared with the private sector. And because there's going to be a real need for partnerships there. So I think we're looking at a innovation pipeline that I believe needs to be in the hundreds of millions of dollars, and then that needs to feed these larger scale demonstration projects and early deployment, which really will depend on either some cost sharing or from the federal side, either credit support or tax credits.
Got it. Great. Great. That should be it for our questions. I want to, first of all, once more, thank you, Joe, for a very interesting and engaging talk. And really appreciate your time. And Natalie Volk from EFI just posted a link to take a look at the carbon dioxide removal frontier reports that you have produced. So please to our audience participants, take a look at that.